Hi, welcome to the channel Coders Arc, where we unravel the world of coding and architecture together. And today I'm going to talk about AWS WebSocket API gateways. I will cover the differences between WebSocket APIs and the traditional REST HTTPS APIs. I will also cover the core concepts of onConnect, onDisconnect, and send message handler of the WebSocket APIs. I will show you how to persist a connection between a client and a server and use that persistent communication to send messages bidirectionally. I will also cover some common gotchas and some common mistakes that most developers and architects make while understanding the core concepts of WebSockets. In this video, I will cover two different scenarios. One, where a WebSocket client wants to communicate with other WebSocket clients and use the WebSocket server to broadcast the message. And the other concept I want to illustrate is when a long running task is happening on the server, and the server, once it finishes its task, sends a response back to the client using the WebSocket connection. I will cover both of these examples through code snippets and architecture diagrams, so let's dive right into it. So let's unpack the definition of WebSockets. WebSocket is bidirectional full duplex protocol that is used in the scenario of client-server communication. However, unlike HTTPS, it starts with WS or WSS to indicate the WebSocket secure. It is a stateful protocol, which means that the communication between client and server will stay alive until it is terminated by either party, the client or server. After closing the connection by either of the client and the server, the communication and the connection is terminated from both ends. So let's take a look at the architecture diagram. So what you're looking at right now is the concept of WebSockets through a diagram. You see that there is a client application that initiates the request to a server for communication. And the server responds to that request using a handshake response. And once the request and handshake process is done, a WebSocket connection is set up between the client and server, and it stays alive until either the client or the server explicitly terminates the WebSocket connection. How does the WebSocket API Gateway works in AWS? If you look at this diagram, on the left side there is a front-end web application which is representing the client. It uses the AWS's WebSocket API to make connection to the server. Now, as you can see that the AWS provides three different handlers, which are essentially three different Lambda functions that would be Lambda integrated with the WebSocket API. One is the onConnect method, the other one is the onDisconnect method, and finally there is the send message method. All three of these Lambdas will be hooked up to the WebSocket API gateways and will handle the connection, disconnection, as well as the message handling portion of the WebSocket connections. Now, to persist the connection ID, all three Lambda functions will work with the Amazon DynamoDB, which essentially stores the connection ID. So we will see all of this working through an example when I walk through the code as well as the AWS console. But for now, all you need to know is that there is a WebSocket API gateway which has three different Lambda handlers for the onConnect, onDisconnect, and the send message. Now, let's talk about a couple of scenarios in which the WebSocket server will respond back to the client. On the top right side, you see the solution that we've already discussed, where the WebSocket server will have the onConnect, send message, and onDisconnect handlers to handle the connection, disconnection, and the send message portion. Now, if you look carefully, there is an arrow, a blue arrow that goes from the send message back to the client and all the way to some other clients. So this is the most common example that you will see in most of the YouTube videos. The incoming payload to the send message method will contain the connection ID because that's what it's looking at. And this will be the connection ID of the WebSocket. And I will show this all in detail, but it's going to contain the connection ID information, the WebSocket information, and any payload. And then this payload is sent back to the client or some other clients that the WebSocket server has connected to. So this is a more common pattern that you will see in most of the YouTube videos. But now I want to talk about a little bit more complex scenario. For example, there is a client and it has launched a task in the background, and that task takes a long time to complete. So imagine like a job that's running and it takes like a couple of hours, like maybe a data migration job or file upload job, or it could be any kind of a processing job that is running in the backend, and that job takes a long time to complete. So now instead of getting the payload which contains the WebSocket information as part of the send message, this Lambda function has no idea of what the connection ID is and what the WebSocket information is. So in that case, you want to make sure that you are, whenever you make a request from the client to the server for a long running task, you pass the WebSocket connection ID in the incoming request and make sure that the incoming request that flows from this Lambda function all the way through the queue to another Lambda function that is performing a long running task, or it could be a Fargate task, that you're passing the WebSocket connection ID all the way through. And that way, this Lambda function or a Fargate task, which is a long running task, whenever they're ready to respond back to the client, they can use this WebSocket connection ID. So hopefully this will become much clearer when we look at both scenarios through the examples. Let's take a quick look at the code. I have used the AWS's Visual Studio Toolkit to create the WebSocket API methods. These methods are created using C#, but you can use any other programming language like Python, Node.js, or Java. Essentially, the code will create three different methods: the onConnect handler, onDisconnect handler, and the sendMessage handler. If you look closely, you will see that all three methods take the API Gateway proxy request as one of the parameters. Now, one important thing to note over here is that there will be a Lambda function for each one of these methods that is hooked using the Lambda proxy integration to the WebSocket API Gateway. So what that means is that there will be one Lambda function for onConnect handler, one Lambda function for onDisconnect handler, and another Lambda function for sendMessage handler. If you look closer to the onConnect handler method, you will see that the incoming request is parsed to get the connection ID, which represents the WebSocket connection ID, and then it is persisted into a DynamoDB so that it can be used at a later stage in the flow. This is very, very important step to know, that on the onConnect handler, the connection ID is retrieved and saved in the DynamoDB. Now I'm zoomed into the onDisconnect handler, and the same thing happens over here. The API Gateway proxy request is parsed to extract the connection ID representing the WebSocket connection ID, and then if there is an entry that exists in the DynamoDB, it is deleted from there, which means that whenever the WebSocket connection is closed, the persisted WebSocket connection ID is also removed from the DynamoDB. Finally, let's take a closer look at the sendMessage handler, which is very similar to the onConnect handler and the onDisconnect handler, because it takes the API Gateway proxy request as one of the incoming parameters. The code parses through this request to extract two things. One is the WebSocket connection details, and the other is the payload. Now, this is a simple scenario where one of the WebSocket clients is trying to broadcast a message to the other WebSocket clients using the WebSocket server. So here, the code parses the payload and then searches the same DynamoDB. The DynamoDB where the onConnect handler and the onDisconnect handlers are using to save the connection IDs and remove the connection IDs from, it's the same DynamoDB. So because that DynamoDB contains all the active WebSocket connections. So it's very, very important that you remember this. So the code parses through the DynamoDB for all the WebSocket connection IDs, and then to broadcast that message, it uses this post connection request right over here, and where it contains the data, which is the field which contains the payload to be broadcasted. And finally, using the post to connection async call, the method sends or broadcasts the payload to all the active WebSocket clients. Now this is a very simple scenario. I will talk about the other scenario which we discussed, which is about handling the long running tasks. I have commented this out for right now, but essentially this is the code that will be implemented if you're trying to run a long running scenario. And here you need to make sure that you're passing the WebSocket connection ID details in the incoming payload. So we'll talk about that in just a second. So Now I am finally zoomed in on the method, the handle long running task scenario. In this method, I'm just trying to create a simulation. Essentially, what I'm trying to simulate is there would be a long running task that is running in the background, and that task will respond back to the WebSocket connection ID. So essentially, you want to make sure that the long running task needs to get the WebSocket connection ID details so that whenever it's done with its task, it can respond back to the WebSocket client. So if you look closely at the payload for the SQS message, I am passing the domain name, stage, but the very important field is the connection ID field, which is the connection ID for the WebSocket client. And finally, whenever the long running task receives this payload, it will extract the WebSocket connection ID from this incoming payload. And then whenever it completes its task, it uses the same code, if you remember the post to connection request and the post to client async code, to send the message back to the client. I now have zoomed in my code to the fake long running task that was implemented in its own Lambda function. So I have now switched the solution. It's a different solution. As you can see, it's a fake long running Lambda for WebSocket POC. And essentially what this function does is it takes the incoming payload, which is in the form of an SQS event, SQS message, and it extracts the staging information, the domain name information, as well as the connection ID field. It's very important. The connection ID field is the key over here. So now once it extracts the WebSocket connection ID field, it knows the identifier of the WebSocket client that it needs to send the message back to. So it will parse the same DynamoDB, which contains the active WebSocket connection ID details, and make sure that if there is a connection ID that exists in that table, and if it matches the incoming payload's connection ID, then it can respond back to the client. So if you look at this line of code right over here, await API client dot post to connection async using the post connection request, and the post connection request contains the data that the server wants to send back to the client, as well as the connection ID field, which is the WebSocket connection ID field between the client and the server. So in this example, what I'm trying to illustrate is that you can loosely couple these applications. You don't necessarily have to implement all of the server-side functionality in the send message handler. You can decouple it, move the code to a long-running task, which could be a Fargate or a Lambda function, and whenever those tasks, those long-running tasks are completed, if you have the connection ID details, which is the WebSocket connection ID details, you can respond back to the server. You can respond back to the client. So now we are in the AWS console, and I wanted to show the WebSocket API Gateway using the AWS console. As you can see, this looks very different than the REST API gateways that you've seen previously. There are three different method handlers: the connect, disconnect, and the send message handler, like we had discussed previously. Very important field is this request body message field. This is very important because this is where most developers make the mistake. They're not able to understand this field and the importance of this field and how it helps to route the messages appropriately. So I will discuss that in just a second. But let's take a look at the connect, disconnect, and the send message handlers. As you can see that they are connected using the Lambda integration to their own respective Lambdas. So if you remember the code that we showed previously, there are three different methods for three different Lambda functions for each one of these connect, disconnect, and send message functionalities. So now I want to emphasize on the importance of the route selection expression, which is the request.body.message. Essentially, you can create any route and can have any route selection expression. But I just wanted to show how the incoming payload from the WebSocket client should look like so that the message is routed appropriately to one of the handlers. So here on the right side, you see the React application code, and I've highlighted the incoming payload. Essentially, it contains a field called message, and then inside that, it contains the send message. So this is very, very important because the request.body, after that, the message represents this message, which is in the incoming payload, and then it's hooked up to the send message handler. So this is where you need to pass a send message handler. So it's very, very important. Most developers do not understand this, or incorrectly understand it, including myself, and I've spent a lot of time trying to debug why my WebSocket client is unable to communicate with the WebSocket server. So this will save you a lot of time. Now that we've covered the theory for the on connect, on disconnect, and the send message handler, and that we've also looked at the AWS console and how these methods are deployed using various Lambda functions, let's cover it through a working example, through a working application end to end. So this React application might look very familiar to you because I've done videos for it using the SageMaker training and testing job, but you need to pay attention to the bottom half of the screen where we are getting the WebSocket response. But before we look at the WebSocket response, let's take a look at what the DynamoDB looks like. So right now the DynamoDB has no entries, which means that there are no WebSocket connections created between the client and the server. So when I refresh this app, essentially, let's take a look. When I refresh this app, in the connect WebSocket handler, I create a new WebSocket connection. So continue, and essentially it refreshes and creates a new WebSocket connection. So this should have created an entry in the DynamoDB. So let's refresh this, and as you can see, there is a WebSocket connection ID which represents the connection between the client and the server. So now going back to the application, now I want to make a call to the server so that the server can respond back and put a message back to the client. So I make a call. Finally, the WebSocket server responds back, and as you can see, the incoming payload is the long-running Lambda completed its tasks. So I can show you what the server code looks like that generated this message. So if you look at no, not this method. This is the fake long-running Lambda, and here, if you remember, this is the payload that it was sending. Long-running Lambda completed its tasks. So the important thing to note over here is that there is a persistent web connection between the client and the server, and whenever the WebSocket server completes the long-running task, it sends a message back on that persistent WebSocket connection in real time, so that the client does not have to poll the server to get the response. So this is an added benefit and one of the most important reasons why we use the WebSocket connections. Otherwise, imagine the scenario where there is a long-running task and using the REST API Gateway. So in the REST API Gateway, you cannot really predict when the long-running server has completed its task. So what you would do is you would set a polling timer and periodically poll that REST API endpoint to get the server response. The problem with that is if you have many clients and depending on your polling interval, it can cause throttling on the API gateway. So WebSockets remove that problem, and whenever the long-running task is completed, the WebSocket server uses the WebSocket connection ID to send the message back over the WebSocket connection. So in this video, we have covered how a WebSocket connection works and how to persist a connection between the WebSocket client and the server, and using the DynamoDB to fetch the connection details and send the response back to the client. I have skipped through some of the portions like showing you the IAM permissions needed on the various Lambda functions, as well as showing you the CloudWatch logs. But I hope you will try this example on your own so that you can build a better understanding of the flow. So finally, if you found the value in this content useful, please hit the subscribe or the like button, and also let me know in the comment section what other videos you would like to see next. But for now, goodbye.